So the robot behind me over here is called a KUKA Mobile Robot. It's primarily used to transport samples around. Inside this workflow, we also have different robots that are there to synthesize, to perform reactions, to synthesize them. And we also have analysis robots such as liquid chromatography, mass spectrometry, and NMR spectroscopy as well. These robots are really designed to be modular automation. They're designed to work alongside human chemists in a standard organic laboratory. And they're designed to conduct experiments that we wouldn't normally do ourselves, for example. Here in our lab, they transport samples back and forth, they analyze the data, and they decide what to do next based on the results that they've been given, similar to how a human chemist would work.
So effectively, it's mobile-based, which I'm sure you've seen some in the Amazon warehouses, with a mobile robotic arm. So effectively, the mobile arm is able to pick up and then place items that's on the base itself, and the base is able to drive around and then able to do load chemicals into various stations. And it's also able to even partake in parts of the stations to help move valves within the station. It's great. It's a really huge time saver. So my reactions can take up to 3.5 hours, 2.5 hours. But if I'm doing it from back to back with the amount of reactions I need to do, every 2.5 hours I need to come back and then I need to do more reactions. Whereas in this case, I can set up multiple reactions to run, and then I could just, well, I could do other stuff. I'm free up, the time is free up, but it's also when I'm at home at night, I don't need to be back every 2.5 hours to make sure that it continues running, because it's able to run throughout the night.
These robots are used to try to optimize some type of chemistry experiment. So that could be a chemistry experiment with a bunch of different inputs, and we're trying to maximize one output that we would measure. So the possible combinations of that is just a lot, sometimes millions and millions of different combinations, reactions that we could try. But since we don't have time to try all of them, we need some type of intelligent way to decide which experiments we will try next. So that's where the AI part comes into play.
when COVID happened, everyone realized that like accelerating discovery of a new drug is actually really important. And since then, and the developments of AI and maturity in robotics area, putting all together, it become possible to explore large chemical space using integrated AI and robotics platform. Robot excel at repeating well-defined tasks, but real experiments often surprise you because a protocol might run perfectly well with common conditions, but when you need to deal with multiple different chemicals, actually it can behave very differently. So at that point, human need to make decision. Human need to design experiments, human need to interpret unexpected or even expected results and making creative leaps.